Now in this example, what I wanted to show you was the effect of endianness. As I told you during the tutorial that the SPIM simulator simulates a little endian processor, and as a result of that, the order of bytes is reversed within the words. So here we have the example of the string where declared a string from A to Z, and as with the data type of ASCII. So what this string is actually, it is represented in memory in the data segment as a string of bytes that ends with a 0. Now to show you the effect of endianness, I'll take you to the SPIM simulator and how the data segment is set up within the simulator. As you can see that we can see some hexadecimal digits, some numbers within the data segment. The 61 you see in those 8 bytes in the first word, and that is the least significant byte within the first word. That corresponds to A. The hexadecimal code or the hexadecimal value for A is 61. And the next significant byte, 62, corresponds to B, 63 corresponds to C, 64 corresponds to D, and 65, which is the least significant byte of the next word in the data segment, corresponds to E, and then F, 66, G, 67, and so on. Finally, we see that the string ends with 7A, which is the hexadecimal value for Z, and then the 0 terminates the string. Now it's important to note that if this were to be a big endian machine, the ordering of the bytes would have been reversed within the word. So we would have seen 61 in that location in the most significant byte instead of the least significant byte, and a similar thing for 62 and 63, that would be inverted, and then 64, instead of being the most significant byte, would have been the least significant byte on a big endian machine.